Hello and welcome everyone to the Ajuno Fly Smarter Inspect Better webinar, where we will be covering AI-enhanced drone inspections. We're very excited to have you with us today. My name is Maalouf. I'll be your host for today. I'm a PhD candidate at the University of Southern Denmark, working on enabling safe beyond visual line of sight operations of drones. I'm part of an EU-funded project called Wild Drone, where we aim to use drones for wildlife conservation, both in the EU and Africa. With me today, I have Liam Flood, drone technology lead at Ajuno, and Albert Mansour, CEO and co-founder of ConeLabs.ai. Before passing the mic to you, Liam and Albert, so you can present yourself, I would really love if everyone could take a minute to type in the chat where you're joining us from today, your name, which company you're from, just to get to know the people with us today. And in the meantime, if you want, Liam, I will give you the mic so you can present Ajuno.
Perfect. Thank you very much, Guy. And good afternoon, everyone, or good morning, wherever you are in the world. So my name's Liam Flood. I'm drone technology lead for Ajuno. As Guy mentioned, I'm a chartered civil engineer, and that's how I started my career, focused on inspection, construction of civil assets, and that's where I really developed my passion and interest for drones and the benefits that they can bring when it comes to the inspection market. So working at Ajuno, we're a drone technology consultancy that helps end users to adopt and benefit from drone technology. We work across two key areas, the first being supporting emergency services and healthcare to use drones for emergency response. And the second one, and what's relevant for today, is working with national infrastructure organizations and environmental organizations to help them grow and scale their drone businesses. So super excited to be speaking to you today. And with that, I'll pass over to Albert for an intro and a little bit about ConeLabs.
Hey, good afternoon, everyone, and good morning to those in North America. I am Albert Mansour, CEO and co-founder of ConeLabs. ConeLabs was founded last year. We're located in Waterloo, Ontario, Canada. Our co-founders are licensed structural engineers, that's myself, and also AI engineers. So we are at the intersection of structural engineering and AI, and we've created a product that addresses the resource-intensive manual task of inspection. And our goal is to automate this inspection process and save lives.
Great, thank you both very much. Before we dive into the technical presentation, let me go very quickly over today's agenda. So first, we'll start with a presentation from Liam, who will give us an overview of the evolution of AI. So he will talk about the benefit of AI to UAS operations and the key enablers of AI. After that, Liam will again give us another presentation, walking us through the different stages of the workflow of AI inspection and how we can utilize AI in each of the different stages of this workflow. Finally, make sure to stick till the end because we will have not one, but two use case demonstrations. The first will showcase how we can benefit from AI in the planning stage of your operation, so before even the operation takes place. And the second use case demo we will have will look at how you can use AI after your operation took place to analyze and visualize the data that you have collected. Lastly, also some very quick housekeeping. The webinar will only be 30 minutes long, but we will have some time for Q&A at the end. So throughout the presentation, if you have any question, there should be a Q&A section towards the top right or the bottom of your screen, depending on which device you're using. So feel free to drop questions there. And finally, the webinar will be recorded and shared on social media. So make sure to follow Ajuno on LinkedIn if you want to rewatch the webinar later. I will drop Ajuno's LinkedIn in a minute in the chat. A last thing before we dive into the presentation, we have a quick poll for you. So I would love to know how confident are you in your knowledge of AI in the context of UAS inspection? And you should see the poll any minute now. That being said, Liam, I will pass you the mic so you can start with your technical presentation.
Perfect. Thank you very much, Guy. And it's really great. I'm just looking at the chat now and I can see a number of you dialing into the webinar today from all over the world. So that's fantastic to see. And yeah, really excited to be talking about some of the recent advances in drone-based artificial intelligence. So as we kind of look at the rise of drone technology, and specifically here, we're thinking about the rise of drone tech over the past 10, 15 years for inspection uses, it really kind of started to gain popularity and use around sort of 2012 or so, as we saw the early commercial systems begin to be available. These were the first types of commercial off-the-shelf systems. Some of you may remember the DJI Flame Wheel. Following that, the DJI Phantom were some common systems. And these sorts of systems often had GPS that helped with stability and flying, but were very much kind of manually operated. There would be a pilot flying the system, manually capturing inspection photographs or video. And it wasn't until around sort of 2014, 2015 or so that we actually started to see the rise of automation within drones and real popularity in flight planning software that helped pilots to actually plan out missions. They could draw an area, a box around an asset they wanted to inspect, and the software would help the drone to fly and capture imagery or video of that asset, and actually to take photographs at set frequency. So very much still the pilot was involved in that and flying, but starting to see the rise of automation. And it's been over the past couple of years or so that we've started to see this automation grow in complexity, grow in benefit, and really be able to bring more and more benefit to the end user. So we look at some examples here over the recent years, and you've may have heard of the term drone in a box. So these are automated systems that can sit on construction sites, infrastructure sites, and be remotely operated by anyone with the right authorization from anywhere in the world to fly missions on a repetitive basis or as needed. And there's systems now that have artificial intelligence-based navigation within them to help build that kind of 3D live view of the world that help them navigate the world and ultimately to carry out their mission. So as we are here, 2024, well way through the year now, what we see as kind of the key emerging trends and the continued growth, and where the real benefit of artificial intelligence within drone technology is going to come from, is swarming operations. So broadly, what we mean here is multiple drones flying, working on achieving a common goal. So it's moving away from kind of the status quo, the way things have gone at the moment with one pilot to one drone, and moving to the ability for maybe one remote pilot to operate and to give inputs to multiple drones. And beyond that, even again, the ability then for a human to be taken out of the loop and the drones to fly fully autonomously, capturing data, carrying out missions to the benefit of the end user. Maybe it's an asset owner on an infrastructure site, maybe you work in construction and you can see benefits there in your sites. So super exciting, and I think we're at kind of the start of a really exciting phase now when it comes to drone technology. The regulations are progressing well and will start to enable this more and more and more. So really exciting. Just to dig in then about how artificial intelligence technologies are helping this transformation. I mentioned there increased automation, and that's a really big one, enabling kind of remote drone in a box operations, automated building scans with the potential for there not even needing to be a pilot there on site. So really helpful. Safety is obviously a huge case, and it's a huge reason why drones are used in the first case, to avoid the need for humans to scale heights or to go into confined areas. And now with artificial intelligence, systems are able to build those live worlds of view of the world around them, and they use that to navigate. And that can be especially useful in areas like very busy construction sites, infrastructure sites with pipework, steelwork, lots of complexity that traditional obstacle avoidance systems often struggle with. With AI, they're now able to overcome that. And also that can be really useful in GPS denied environments as well. So there's no need for GPS anymore when it comes to these vision systems. So that's a recent way that AI is really helping to transform the drone ecosystem. The third and final point I'd like to pick up on is around the increased value. Ultimately, these systems, you're flying these systems for a reason, and that's to capture data. So what value can you get from that data? Now, there's some really exciting systems and technology out there, and ConeLabs is leading the way in that regard when it comes to automated data processing and automated feature and issue identification. So this is taking a huge amount of workload off of people and automatically identifying damage to structures such as corrosion or cracking, and highlighting that to the engineering team so they can act faster, act more efficiently, and spend more time on those high value engineering tasks rather than kind of searching for that needle in the haystack, as it were. Moving on then and looking at some novel use cases, we've just picked a few here just to show you some really novel, really exciting ways that artificial intelligence is helping across a number of use cases within drones. The first is search and rescue, and the Romanian search and rescue organization are using artificial intelligence-based drone vision systems to help them find missing persons on the mountainside. And tests have shown that this is actually faster and more effective than a human eye when looking at a screen, and able to find those people safer. It's also able to then send the location of those people back to the response team so they can go and help them and bring them to safety. As we look more into the logistics world, inventory world, it's quite common in large warehouses, think Amazon warehouses, think huge distribution warehouses, that people are manually going around and recording stock checks. How many items of certain types of stock is there? Not only is this not very efficient, it's also potentially has a health and safety risk when people have to scale racking to manually view how much stock is left. And there's a rise now in drones being used to automatically do this. And they're able to do this 24 hours a day, especially times maybe when the warehouse is less busy. They can fly around, manually take those stock checks, and actually update the master system then without the need for the human involved. And that can allow the humans to spend more time on those high value tasks. The third and final one, just to pick up on, is around swarming. So I mentioned swarming as kind of one of the key changes we see over the next few years. And an American-based company called Shield AI has actually developed a swarming software that allows drones to work together to carry out a mission. That might be delivering items, that might be taking photographs, making inspections. And what's really unique and interesting about this is that it's able to operate in a communications and a GPS denied environment. So the drone has a mission, and using the artificial intelligence is able to actually figure out how it best carries out that mission, working with other drones as part of a swarm to make that happen most effectively. We see this is mostly happening now in the defense space. However, this type of technology we expect to be filtering down into the civil market over the next few years or so. So some really exciting use cases there. Just wanted to highlight for you. As we move on, we look at the drone capture workflow. So we're thinking here about how you would plan, carry out, and get value from a drone inspection flight. So we find this workflow is something that our customers find really helpful to help structure and view the key stages of their drone inspections. And just to move through the key stages here, the first one is specification. What is the aim of the inspection? What do you want to get out of the end of it? It's a really, really important part. Ultimately, then you move on to the capture part, and that's when you're flying the drone to capture the data that's needed as part of the inspection work. The third one is around processing. So once you've got the data, what do you do with it? In its simplest form, this might just be sharing the raw drone images with one of your internal customers or external customers. But it can also rise in complexity and benefit to generate 2D and 3D models as well, which you can then kind of create a digital twin of your asset. So that's really, really exciting. The fourth point, and this is when we really start to see value coming from the drone data, is the analysis. And as I mentioned, it's quite common that people spend a lot of time manually reviewing photos, maybe tens, hundreds, if not thousands of photos to look for defects. And there's a rise now in the use of artificial intelligence to automatically find these defects, bring them up, highlight them to the engineering and asset management teams so they are able to do something about it. The fifth and the penultimate stage is visualization. So it's really, really important to be able to visualize, collaborate, work together with that drone data to make a decision as an organization. Simple way of doing this might be on a computer screen viewing the model. We're seeing a rise now in the use of augmented reality headsets where people can kind of be in the digital twin of the model, or able to go around and can even host meetings within the digital twin, which is really, really cool technology, and allows teams all over the world to collaborate, to work together in one virtual environment. And the final point, you could argue the most important one, is acting on the data. So really, really key there. Once you've got all of the information you need, it's making a decision, acting on the data. And just as a practical demonstration of how artificial intelligence can help here, looking at the specification stage, so when you're kind of looking at the drone flight, this is something that all of you would be able to implement and kind of start using artificial intelligence right after this webinar. So I've just picked an example. Now, many of you will be very familiar with large language models, chatbots as they're sometimes called, the likes of Chat, GPT, Google's Gemini have often been in the news over the past year or so, and most are free, easy to use. And actually, in this case here, as you can see, I'm using Copilot, which is now part of the Microsoft suite. So a number of you within your organizations may already have access to this as a free system, and it's built on the latest large language models. And it can be really, really useful to help with the specification stage of your drone flight. And I'll just break down now how you might provide a prompt to that system in a matter of minutes and get a really valuable output back. So the first thing to detail within your prompt is the task. So in this hypothetical scenario, I want to run an inspection using my drone on a large distribution warehouse. I want to capture some images and video, so I've entered that into my prompt there. The second point, and this is really important, is to provide some context. So what I want to look for, and I've added some additional context here, which is there's been a recent storm event. So, that's the impetus for the survey. Third point, really important, is the instruction. What do I want the AI to provide me as an output? In this case, I want an inspection plan that tells me key parts of the structure that I should be looking at. And that's really what I want my response to be. The final point is clarification. So you can actually add some additional information. You can reiterate your main points. You can also provide some information about how you want the AI to structure the response. This only takes a matter of minutes, but in a matter of seconds after kind of entering that into the AI, you get a response. And I've chopped down kind of the full response just so you can see the key sections here. And what's really beneficial about this is in the response, it started to kind of break that warehouse structure down into its key component parts. It told me areas to look at, what to look for example, water leakage, damage to tiles after this storm event. Really, really helpful, really simple to do. Additionally, it gave me some further information, including a link to a white paper, some web links to find more out about this subject, and also the ability to kind of export and download that into a Word document I could then take into my task plan. And this is something that's very simple to do. You can go more advanced than this, but it can really help kind of those first stages of specifying a drone flight and understanding what you should be looking for and how you should be setting that up. And it's really easy to do. So something I really encourage you all to do is to just have a little play, use these systems and see the value and benefit that they're able to bring to you. So with that, we're going to launch a quick poll now, and I'd just like you to think about your current inspection workflows and where do you think they would most benefit from AI? Is there a particular part of the workflow where you think AI could offer some real benefit? So there's a poll just launched there, and I encourage you all to review that and to send us your responses. And with that, I'll just hand over to Albert now from ConeLabs. And just a quick note, ourselves at Ajuno, we look to partner with leading organizations all around the world to help kind of those organizations who are leading the field. And we see ConeLabs as absolutely a leader in the field of automatic drone image processing, photogrammetry, model hosting, and artificial intelligence. So with that, I'm really excited to hand over to Albert for a live demonstration of the ConeLabs system now.
Yeah, thank you, Liam. I appreciate it. I'm excited to show you kind of the process, analyze, and visualize of data that we do here at ConeLabs. So again, our focus is on the inspection of structures. So I wanted to show how we upload the data. So from our website, you simply log in. This could be a live demo, but just to make sure we don't risk any technology failures, I've pre-recorded it. But it's as simple as choosing new, upload data, and then you grab the images from the drone. So it could be tens of thousands of images, but it's a simple drag and drop function. And from that, as the images upload, and you'll recognize some of these images in the model I'm about to show, I rename the model. And then once the images are uploaded, a process to 3D button appears here. And it's as simple as clicking that button. From that, the data is stitched together, and we use the imagery and the metadata that's tagged to the imagery. So we use sensor fusion to create hyper-accurate photorealistic models. And here you see the model is only limited by the resolution of the images. We've built out an entire feature set of tools on the left here, including this one, which we call the paint tool. So users can annotate and also draw over. So, I will show you the AI part in a second. But in addition to that, we have things like this painting tool. So you can communicate with your colleagues, with your customers, specific areas of the model. Now, we've also added features upon request from our users, such as what we call the 2D image viewer. So here we have a stitched model that the raw data was tens of thousands of images. If users wish to see specific images or the two-dimensional data, we have a tool where you simply hover over an area of the model, and you see I hovered over this little white patch here, and all of the 2D imagery that contributed to this part of the model appears here on the left. We also have measuring tools. So I took a measurement of an object here, and then annotations. So we can tag, annotate. You'll notice that discoloration I focus on again. And then once I put the tag on there, I turn on the tagging or the annotation layer, and you see discoloration appears. Again, a way to communicate, you see measurements and discoloration. Our viewer also includes a summary of all of the annotations, distance measurements in a table that can be exported and can be shared with customers, colleagues, and other stakeholders in the project. And then, of course, AI. So we automatically detect cracks, spalls, corrosion. So you'll see here, if I had to manually do it, I would have to rely on, today, imagery or this two-dimensional data set. But our AI will then scan and automatically detect things that we're looking for today. So you see cracks, you see corrosion, and you see spalls. In addition, we can compare this scan to, say, last year's scan, for example. So we have a split screen function where I can open this year's scan, and I can open, and sorry, this is April 23, and then March 2024 scan opens up here. And I will turn on the AI layer for that and instantly have a visual of what has changed in the model from previous years, which is a significant part of the task that we perform today as structural engineers. What has changed, what has propagated, or if we took remedial action, was the action effective? So this is a side-by-side tool that we've created, and each crack has a unique identifier. It's categorized, it's located with hyperlinks, giving our users the ability to input all of the data into a report. So that's our platform, the ultimate viewing image inspection, or the ultimate inspection platform that we've created.
Thank you very much, Albert and Liam, for those amazing presentations. I would like to also thank everyone for joining us today. I will do a quick recap of today's webinar. So first, we started with Liam's presentation talking about the evolution of AI, where we saw how drone operations evolved from manually piloted drones all the way to fully autonomous swarms of drones, at least in the future, hopefully. We also saw the benefits of using AI in UAS operations to increase automation, safety, and get more value out of your operations. And you also had a quick look at the key enablers of AI, which are mainly the development in processing powers, so CPUs and GPUs, machine learning algorithms, and edge computing. We also then got an overview of the inspection workflow by Liam and how to utilize AI in each of its 6 stages. And finally, we concluded with 2 use case demonstrations, where first Liam showed us how we can use large language models to plan our missions, and then Albert showed us how we can analyze and visualize drone data and utilize also the drone data using ConeLabs platform. Now I'll move into very quickly into the Q&A. So we did receive a few questions. The first one, I think, is probably more for you, Liam. Yassine asks us, what happens if drones carry and transfer merchandise in an unpredictable storm? Are there alternative measures that you could take?
Yeah, it's a really good question. And I think something that, with traditional logistics, ground-based logistics, such as vans and lorries, we've gotten used to them working kind of all year round in a range of different weather scenarios. And usually, and I'm speaking for the UK here, it's only really snow events really that stop that from happening and stop those vans and lorries being able to get to where they need to. When it comes to drones, ultimately, because of the technology, because they're flying, they are more susceptible to the weather conditions, especially wind. So, there's a number of systems available now that are weather rated for rain and are able to be flown quite safely and reliably in very rainy conditions. However, when it comes to wind, that's still a limitation of the drone technology. They're lighter and smaller than commercial aircraft, so they do get more effective. And typically, most systems we see are able to operate up to around sort of between 12 to 15 meters a second of wind. Beyond that, they will start to struggle. So as part of any kind of drone logistics program, it's really important to have backups. That might be electric vehicles, vans, and so on that are ready to go. And also what we're seeing in a lot of the large drone logistics companies is they're able to build in predictive forecasting of weather to actually plan for those events and make sure if the wind is too high for the drone to fly or there's a storm event, that there's already kind of ground-based vehicles ready to go, so that delivery of critical items is able to continue.
Thank you very much, Liam. There's another question, actually. I think it's more targeted towards you, Albert. Will asks, how does ConeLab integrate with, I think, GIS solutions from organization like S3?
Yeah, we have full integration, so full ArcGIS integration. We can also geolocate our models as long as a control network is present. So full integration with these GIS platforms.
Perfect. And Liam, actually, I have a question for you because when we shared the second poll about where people believe they could get more value from using AI in which stage of the workflow, most of the votes came for stages 1, 4, and 5, but no one really voted for stage 2 or stage 3, which are like capturing or processing the data. And then I also know that you already worked with the Skydio drones and at Ajuno to capture some data. And I was thinking maybe you could tell us more how AI is used in the capture part or the processing part of the data.
Yeah, and I think focusing in on the capture part, that's when the drone's flying, capturing the data. In this case, we're very much focused on the inspection aspect of that. So maybe inspecting civil assets such as a bridge or a tower. Skydio, as an example, are an American drone company. And one of the unique aspects about their technology is that they use a vision-based obstacle avoidance system. So rather than some other systems that might use radar-based and a series of sensors around the drone, with the Skydio system, a series of cameras, and there's 6 cameras on the drone, is able to build up a live 3D map of the world. And using a high-powered processor and an artificial intelligence algorithm that sits on board the drone, it's able to use that to build this 3D world in real time and then use that to actually autonomously navigate. And what that means in practice is that Skydio system is able to go through gaps and inspect assets much more closely than a lot of other systems. And there's examples where this has been used in substations, for example, on electrical systems, and it's able to avoid the wires, avoid these kind of complex structures, whilst making sure to, most importantly, fly safely and capture the data that's needed. So that's one really good example. And then when it comes to the processing side, Albert mentioned it. This is something that with the ConeLabs tool is now really easy to do. It's as simple as taking the images straight from the SD card of the drone, putting them into the ConeLab system, and the technology does all the rest.
Perfect. To be honest, I think it's a really exciting time to be in the drone industry, but unfortunately I'm aware of time, so we will need to wrap up this webinar. Before doing that, I just want to mention I dropped our contact details in the chat, so if anyone needs to follow up with us, have any question, please feel free to reach out. And with that, thank you very much everyone for joining us today, and we hope to see you in our next webinar. Have a nice day.